I want to do three things. I'd like to talk a little bit about where we are in understanding the climate changes that have already occurred, what we know about projections, and what we know about solutions. But before doing that, I want to talk for just a couple of minutes about the assessment of climate change and how we think we know what we know. You've probably heard that there are lots of questions now about reliability of science, especially with biomedical studies. And how is it that you decide one study's right and another study's wrong? In climate, we're incredibly fortunate because we've been very systematic about assembling the overall perspectives of the scientific community. Within the last year, there have been highly organized, systematic reviews of what we know and what we don't know from the American Association for the Advancement of Science. It's the biggest science society in the US. The Royal Society in Britain, the main scientific organization of science excellence in the UK, and the National Academy of Sciences in the US, the leading scientific body in the US. All finding essentially the same thing. And in addition to that, we've seen major assessments from something called the Intergovernmental Panel on Climate Change, something that I've been privileged to work with for the last dozen years. And I want to say just a couple of things about the way the Intergovernmental Panel on Climate Change, or the IPCC, works. The IPCC is governmental, intergovernmental, and essentially, 25 years ago, the world's governments came to the scientific community and they said, hey, you scientific community, if you'll follow our rules about doing systematic assessments, we'll consider them the definitive statement of what we know and what we don't know about climate science. And the rules are complicated. They involve efforts to do absolutely comprehensive reviews, to identify author teams from around the world, to go through multiple rounds of independently monitored reviews for the report that we just completed. We had over 50,000 review comments from around the world. Every one of those review comments had to be individually responded to with a separate group of scientists evaluating whether the responses were appropriate. And the process proceeds such that by the time the assessment's done, it's really a product of the entire scientific community. It's not me writing as a scientist or Marion writing as a scientist. It's the scientific community's statement. And then we get to the final approval. The document is approved word by word, by consensus, by all the world's governments. Think about what that means. We're in the plenary approval session for the Working Group 2 report, and I put the first sentence up on the whiteboard and says, changes in the climate system are unequivocal. I say, does anyone agree, or does everyone agree, does anyone not agree that that sentence represents an accurate statement of where we are with the science? You're Kuwait, you're Tuvalu, and you're India, and when I first put the statement up, probably 50 countries would say they're not convinced. And we don't move on until every country is convinced that that is the definitive statement of what we know and what we don't know. It's an amazing process. When you think about it, you could easily imagine that we would never get beyond a one-line summary. But in fact, we do, because the science really is so robustly assembled that it's essentially bulletproof. And so what I want to talk with you about today is the scientific findings of the entire scientific community. Sometimes we talk about it as consensus, but it's not that the science is a consensus. It's a consensus that this is what we understand and this is what we don't understand. So that's the starting point for the material I want to present. And the starting point is really quite profound. There's essentially no doubt that the climate has changed dramatically in the last 100 years or so. We've seen a warming that worldwide has been about 1.5 Fahrenheit degrees. Essentially no question that humans have caused the majority of the changes we've seen over the last 50 years or so. Climate change is not some hypothetical possibility for the future. It's something that's real, it's happening now, and it's also impacting physical systems, biological systems, and people around the world. That's a second major conclusion that I want to talk about, which is that when we talk about impacts, it's not hypothetical impacts about faraway places and unknown species. We've really seen impacts of climate changes that have already occurred. They've been widespread, consequential. We've seen impacts on every continent. We've seen impacts from the equator to the poles and from the mountains to the coast. We've seen impacts on physical systems, the lengths of glaciers, the timing of rivers. We've seen impacts on biological systems, the ranges of species, the timing of biological events, the extent of forest fires, and we've seen impacts on human systems, the amounts of agricultural productivity. We've seen impacts on livelihoods, things like commercial activities with fishing, even transportation. There's essentially no question that the climate changes that have already occurred have had major, substantial impacts. There's also no question that vulnerability to climate change is widespread. You know, we tend to think about vulnerability as most concentrated among the world's poor, people who have limited access to control over their own lives, where inequality creates challenges, where lack of resources means there's a lack of options for dealing with climate. But when you really look about it, what we see is that some of the most difficult challenges are for those people, but some of the least preparation we see in the world's rich societies. And that was really brought home in a really crystallizing way with Hurricane Sandy in New York in late 2011. And there we had over $60 billion of damages from a serious but not unheard of level of storm, and it showed a striking level of lack of preparation. Essentially, we're all sitting ducks, and there's no place in the world that's really prepared to deal with the impacts of the climate variations that we're already seeing, independent of whether those are associated with climate change. There's also no question that we're starting to think about climate solutions. Investments in adaptation, in coping as effectively as possible with the climate changes that can't be avoided are already beginning to occur. We're seeing some kinds of climate adaptations that are heavy-duty engineering solutions, things like flood barriers, where there's a big one in London, there's a barrier under construction in Venice, there's a barrier operating in Rotterdam, big heavy-duty engineering solutions. But we're also seeing lots of community-based solutions, planting mangroves for coastal protection throughout the tropics, societies that are organizing. We've even seen some societies, First Nation societies in Alaska, that have asked to move as a consequence of coastal erosion that's been accelerated by climate change. Adaptation really is beginning to occur. The other thing we can do about climate change is mitigation, to actually decrease emissions of heat-trapping gases and to decrease the amount of climate change that occurs. And we're already beginning to see some progress with mitigation. Even though fossil emissions are continuing to increase, we now live in a world where something like 2/3 of total greenhouse gas emissions are covered by some kind of an agreement. We can talk about whether they're effective agreements, but there's some kind of agreement that covers 2/3 of the current emissions. What it means is that we're beginning to learn, we're beginning to have experience, see what works, what doesn't, what we need to change in order to be more effective. Let me stop for a minute and talk about managing climate risks moving forward before I talk about what those are. It's really clear that the best way to think about climate change impacts is to think about them in the context of risk. And there are at least 5 reasons it's useful to think about climate change impacts in the context of risk. The first is that in a changing climate, we're going to see many of the kinds of things we see now: heat waves, severe storms, coastal floods, hurricanes. But we're going to see a different frequency and a different pattern of them. When you think about risk, you can think about connecting the responses to current variability with the things we'll see in the future. And well, a second reason is that most of the impacts from a changing climate are going to occur in extremes. It's going to be the hottest days, the highest tides, the strongest winds. Whether or not climate change actually changes the strength of those things, where things break in a changing climate is where you're in extremes. And we should recognize that when we want to understand the risk, we need to understand the risk from the extremes. A third reason we want to be really clear about understanding climate change challenge and managing risks is that we want to be focused on the full range of possible outcomes. The scientific community has invested vast resources in understanding the most likely outcomes of climate change, and I'm sure you've heard temperature projections, which give a central projection. But in general, we care very little about the central projections in an environment with risk. When you get in your car and you're happy that you have car insurance, seatbelts, and anti-lock brakes, it's not because you expect to have an accident. It's because there is a full range of possibilities, and that full range of possibilities includes one where the seatbelts, the airbags, the anti-lock brakes could potentially make a difference. So with climate, we want to recognize that even though we have a pretty good understanding of the most likely outcomes, where things really are likely to matter is at the extremes, and we want to make sure that we're sensitive to understanding the consequences of being at the extremes. A fourth reason it's really important to think about climate change as a challenge in managing risk is sort of a good news story, and it's that we already have a wide range of sophisticated tools that we use every day for managing risk. These are tools that are available from the scale of the family to the firm to the government. At the family, it's investments in home insurance, safe vehicles, things like early warning. At the level of the firm, it's hedging your investment portfolio, thinking about depreciation schedules of infrastructure. And at the level of government, it's things like investments in national security, thinking about the time scale of infrastructure. Lots and lots of sophisticated thinking at all levels in society already goes into managing risk. That's exactly the thinking we need to be successful in dealing with climate change. And then a final reason that I think it's really critical to recognize that climate change challenge in managing risk is that climate change in general doesn't introduce dramatically new kinds of problems. What climate change tends to do is add new dimensions, new complexities, and new probabilities to problems that we already face. Problems with severe storms, high temperatures, sea level associated events. And so what we need to recognize in that context is that climate change isn't kind of a new player on the horizon. It's more of a threat multiplier. And as a threat multiplier, we need to think harder about the kinds of solutions that we already apply in terms of protecting societies with early warning systems, with good investments in infrastructure for providing emergency services, and with thoughtful responses to disasters. So from that perspective, climate change looks in some ways more challenging, but in many ways much more manageable. It's a continuum with things that we've already done. As I step away from this topic of understanding climate change as a challenge in managing risk, let me say one more thing. When you look at disasters, what you see is it's not typically the biggest trigger from the natural system that causes the biggest disasters. What typically happens is that disasters represent an overlap between some kind of a trigger from the climate system, we call it a hazard, vulnerability, a propensity to be harmed by the people and ecosystems, and exposure, having things, assets in harm's way. And it's only at the overlap of the hazard, the vulnerability, and the exposure that you end up with a risk of a disaster. And the same is true for climate change. You need a hazard, that's the change in climate. You need vulnerability, the lack of preparedness that we know we all have, and exposure. One of the interesting things about understanding risk of climate change as the overlap between hazard, vulnerability, and exposure is it means there are lots of things we can think about in terms of solutions. One kind of solution is decreasing the hazard, mitigation to decrease the amount of climate change that occurs. But others involve thinking hard about the way society works to decrease vulnerability and exposure, being better prepared and making sure that where we make investments, they're not in the wrong places. Let me talk now with this framing of understanding climate as a challenge and managing risk about where we think we're headed in the future. You know, essentially, you can imagine the future as having two big swaths of possibilities. One swath of possibilities says we totally ignore the risk of climate change and we continue in a world with high emissions. We end the 21st century with a global average temperature that's something like 4 centigrade, about 7 Fahrenheit, warmer than pre-industrial, with a wide range of impacts. The other extreme, we could have a world of ambitious investments in mitigation, holding down the amount of climate change that occurs as ambitiously as possible. And realistically, with ambitious mitigation, we might end the 21st century at something like 2C, about 3.6 Fahrenheit over pre-industrial temperatures. That's about twice as much warming as we've already seen. A substantial amount. We'd see substantial impacts from that. Before I talk about the specific projections for impacts in those two worlds, let me say something about the time periods. It's going to take us a long time to be effective with mitigation. Even with ambitious mitigation, we're going to see impacts of climate changes that are already baked into the system for the next several decades. Essentially, no matter how ambitious we are with mitigation, most of the impacts over the next few decades are already baked into the system. They're baked in as a consequence of the physics of the way the climate system works, and they're baked in as a consequence of the inertia in social, economic, industrial processes. What that means is that over the next few decades, the primary tool we have for dealing with climate change is adaptation. We need to be better prepared for the climate changes that will come. That doesn't mean that we don't need to worry about mitigation during that period. In fact, one of the great conceptual challenges in climate change is for us to be effective at ambitious mitigation to hold total warming to this 3.6 by the end of the century. We really need to be making the investments in the near term rather than in the long term. So what are the worlds with ambitious mitigation or continued high emissions look like? In a world with ambitious mitigation, where we might end the century at something like 3.6 degrees above pre-industrial, we'll still see a wide range of impacts. Ocean will be substantially more acidic. There'll be continued threats to a wide range of ecosystem processes. Ag yields will be impacted around the world such that it's more and more difficult to increase ag yields. And there'll be differences in the kinds of activities that could be pursued in lots of different places. Particularly changes in activity that are conditioned by changes in extreme events. You know, farmers rarely decide to give up on growing crops because every year is below some threshold. The kinds of factors that determine whether activities that occur or how frequently do conditions become unacceptable. So the thing to remember about a world with ambitious mitigation, however, is that the total amount of warming by the end of the century is only about as much warming from now as we've already seen over the last century. In general, that's an amount that's going to be serious, and it's going to take careful investments in adaptation, but it's a level of climate change that in most places can be effectively managed. On the other hand, the world of continued high emissions, a world that's ending the century at something like 7 to 8 Fahrenheit above pre-industrial, is one where it's very difficult for us to make reasonable projections. The way I think about it is that when I'm asked to describe the world of 2100 with continued high emissions, I pretty much say, well, all bets are off. We have a few ideas of areas where traditional kinds of agriculture may not be possible. We have a clear picture of massive redistributions of rainfall such that the high latitudes and the tropics get much wetter. A few parts of the subtropics, Southern California, the Mediterranean, Australia, get much drier. But it's really hard to predict where things break because we're looking at a world that's so much different than the world from now. And it's hard to say whether the primary consequences are going to be serious consequences for human health, which get compounded with issues with food production and delivery of emergency services, or whether in their area of economic activity, where in many parts of the world it'd be too hot for people to work outside during large chunks of the year, or whether they're in ecosystems where there's a risk that a very large fraction of the world's total diversity will be committed to extinction. The way we think about it in the IPCC is there are at least 5 different baskets of issues we care about in the future, and the risk to each of those baskets is dramatically different in a world with ambitious mitigation than a world with continued high emissions. And they give you a feel for the kinds of assets are at risk, and also for why it's so difficult to come up with a simple traditional cost-benefit analysis about whether this is a problem that is worth a given level of investment. The first of these risks is risk to rare and endangered systems. We already know that a few species have gone extinct as a result of climate change. We also know that there are lots of threatened species around the world. There are also unique archaeological and historical sites that are at risk. We've already seen some impacts, and the risk of even ambitious mitigation is far from trivial. A second important category is the risk of extreme events. I've already described the ways that it's super difficult to figure out how to process extreme events in economic terms. A third category that's important is sort of the unfairness aspect of climate change. Many of the impacts of climate change fall most harshly on people who contributed least to the problem, and it's really difficult to figure out how to price the greater impacts on those folks than on the societies that contributed the most. A fourth category is large-scale singular events. We have good evidence that somewhere between about 3 and 6 degrees Fahrenheit, we're likely to see collapse of one of the world's major ice sheets. The sea level equivalent in total melting of the Greenland ice sheet is about 23 feet. And while melting of the Greenland ice sheet would occur over many centuries, once we're committed, as far as we know, we're committed. And there's no question that these large-scale events really could have a huge leverage. And the fifth is the global aggregate impacts on total availability of fresh water, total availability of food, total economic activity. And in some ways, those are the simple ones. Those are the ones we can price. But until we can understand impacts across that whole space, it's really difficult to come up with a simple metric that says how much we should invest. Now, I want to close with some thoughts on solutions that take a different approach to this cost-benefit approach. And it's, instead of cost-benefit approach, it's a co-benefits approach. And we know now when we look at the impacts of climate change, when we look at the things that we're trying to accomplish with adaptation and mitigation, that we're not really talking about trade-offs where we have to pull resources away from sustainable development in order to adapt, or pull resources away from sustainable development in order to mitigate. If we do this right, what we're talking about is investments in adaptation, mitigation, and sustainable development that work together. They work together in a way that helps build communities that are robust, economies that are growing, and societies that are vibrant. How can we do that? We can do it by being thoughtful about an approach that says, how can adaptation contribute to things we need now as well as things we need in the future? How can adaptation help us deal as effectively as possible with the world we live in? At the same time, it builds a sustainable future. And with mitigation, we can say, what are the investments that create a fair playing field, that create opportunities for innovation, and that more than anything else, use investments in the future in order to build vibrant societies and robust economies. And at least for me, the estimates of the cost of climate change pale in comparison to these co-benefits that come from thinking carefully, planning ahead, and being serious about building solutions. Thanks very much. Thank you.
Thank you, Chris.